Okay, let's see. Am I live? Let me step into the control room here. Oh, I guess we are. Cool. Alright, so we're taking a break from JavaScript. We'll get back to it. We might even do one or two in the middle of the broadcast tonight if we feel like it, because I think the next one is actually really easy, so we could just if I feel like it, try to bang it out quickly. But I've been meaning to do this for quite a while, and it's to show the Clojure track tooling. Alright, so where are we here? Okay, so say we're in, let's see. Okay, so say we're on Exercism, but let's go over to the Clojure track. So let's see, let's go to just a nice easy exercise. The lasagna one. How about something like twofer? Oh, you know what? I haven't oh yeah, I did share this stream on Slack. Cool. Maybe I should put it on Facebook too. And maybe even Twitter, if I wanted to get really crazy. And let's see, do I have my chat anywhere? There we go, now I have, but I can also see the chat on the YouTube control room, so I think I don't even need that. I'll just leave this up. This is great. I'm after hours at the office, and I don't have to be in the conference room where we have a 3-hour limit because there's nobody in here. I'm the only one that's crazy enough to want to work after hours. And this might actually work out well because a lot of the people on the team are on the other side of the world. So this late night stream thing might be a really good thing to continue. So before the launch of V3, this was the way we solved exercises. We would do Exercism download, and this is assuming that you've installed the CLI. If not, there's easy instructions to do that for whatever your platform is. And so we would do this Exercism download command. And now there is an exercise located here. So if we go there, we'll say and I'll open up the VS Code. And so this is how an exercise would be delivered back in the day with V2. They would have their source code here, and they would solve it on their machine using whatever tools they want, and using the provided test suite here. And then, well, they would follow the directions for whatever testing framework is used. And there's also instructions on the site for doing that. Let's check that out, actually. So downloading the exercise. Let's see, there should be a track specific. And testing on the Clojure track. Yeah, so this is the incantation to use the Cognitect Labs test runner. And yeah, so that's just CLJ -X test. And so this is using the test alias that runs the Cognitect test runner, which uses the Clojure.test library, and 0 failures. So this must be already solved. Oh, yeah, I guess it is. Okay. It downloaded the exercise. Yeah, this was when I solved it before. Okay, so you could also do line test if Linigan is installed. And this was, yeah, that also worked. VS Code also can run tests, I believe. I don't know if I've ever actually done it through. That's Python. This would actually be in the Calva documentation, which would be good to put on this page, actually. A link to how to do testing within the editor. So this is, I'm using VS Code with the Calva plugin, which is really wonderful. I actually started using VS Code because somebody wanted help getting it working, and so I installed it so that I could help them, and it was so nice that I just kept using it. Okay, yeah, test runner. Yeah, so run all tests is Control-Alt-C, Shift-T. Oh, here, just Control-Alt-C-T for the current namespace. Let's try that. Let's see, let's search for the run tests. Let's see, this would be maybe Calva. Alright, let's see if we can find this command. Test run all tests. Let's just try that. Oh yeah, we need to connect to, so I go cj, and we'll connect to a REPL using deps.edn, and yeah, we'll use the test alias, which will pull in the Cognitect test runner. And I think that's what it's doing now. Alright, and oh yeah, it ran them right there. Oh, cool. So let's see, now if I go Control-Alt-C-T, it's still, let's see, what was the one, run tests for current namespace? Let's see if I can find that here. Run tests in current file. Control-Alt-C Shift-T. I'll try that. I'm not sure why I'm not seeing the testing commands. Well, anyway. So that was, that's what Exercism was. And then once you solved it on your machine, then you would hit go Exercism submit with a path. And, oh, you know what? It's because it just connected and disconnected. That's what happened here. So if I do this without the test alias, then it'll just connect to a regular REPL. And now I could say Control-Alt-C-T. Cool. Except that it didn't find the tests. Maybe try with the capital T. No tests found. I'm not sure. Oh, because we probably didn't load the namespace. So if I go load that, and probably go and load the test namespace as well. Now if I go like this, all right, all passing, and then we get a thumbs up. And then you would say Exercism submit, and that's how you submitted the answer. And as far as track tooling, this is what existed at the time. When I got here, everything is still there. We haven't gotten rid of any of this stuff. It's in this test directory, this thing called check exercises. And this was something that somebody wrote. This was here when I got here, that goes and gets the list of practice exercises, and this defines a test that runs all of the tests using the example files. And this had I think it was part of this workflow here. Yeah, line test. So that was the CI at the time. And then it was time for V3. So we needed to write a proper test runner. Now, this is one of the things that somebody needed to step up to do. And since I realized that if it wasn't me, then nobody else was going to do this. But I didn't know how to write tooling. I didn't even know really what writing a test runner involved. So Eric kind of beat me to it a little bit, and so this is the test runner repo, and there was a run script, which this was actually one that I made, and then Eric backed it up, and then if we look at the history of this, it was this here was the simplified test runner written by Eric, which it runs Clojure. That's the Docker file. So run tests in Docker. Run tests. Here we go. And this is similar to the way I think other exercises work, where that runs run. Right? This one. The command run is line test, which uses the test runner included with line again, which the problem with that is that it just tells you how many tests passed, or how many failed or errored. And in order for V3 to work properly, we needed actually detailed information about which tests are failing, so that we could show feedback on the site when the run tests button is pressed. So let's go back to the Clojure track and open this up in the editor here. And yeah, so what we'll do is let's go to actually a easier exercise like twofer. And what we'll do is we'll kind of like follow the life of a solution, an Exercism solution submitted to the website. So let's say we finish the solution here and run the tests. a lot happened right there, and a lot of it is beyond what I know about or am responsible for. But it took this project, this source code file is located on a machine in the cloud somewhere as a Clojure project file, and it copies it, loads it using a Docker container, and invokes the Clojure test runner. So when v3 was launched, Clojure was not one of the initial languages that launched the first day, but it was the first time that I got to see what we were actually doing all of this time, running these concept exercises, and everyone's working on test runners and analyzers and stuff, and we're having markathons where we would get together and have a big party because we're writing markdown files. And so I was totally inspired because I had never been part of something so huge that took so many people working for years. Actually, we took 2 years building v3 and launching it, and so suddenly all of this stuff that we were talking about that was just kind of theoretical was actually working. And I was recovering from COVID, and out in the wilderness, with barely an internet connection, when I started working on this. So it all starts with Clojure.test, and that's what this test runner was using. And unfortunately, it was kind of slow because it's Clojure, and it uses the JVM, which actually it's not just the JVM that makes Clojure slow to boot. The JVM is responsible for about a second, I think, but it's loading all of the Clojure core library and all of those Java classes. It takes a while, especially if you're using line again, because then it actually uses 2 Java virtual machines. And so that takes twice as long to start up. And so I had this kind of crazy idea to use Babashka for the Clojure test runner, which is it's an interpreted version of Clojure that runs natively. So for the purpose of, and there are some differences, but I figured for the purposes of Exercism, it would be close enough. Part of my, what actually made me think that was maybe a viable thing to do was when I saw Martin Cavallar's presentation on Clerk, which is NextJournal's local first computational notebooks. And he said that they were using Psi, the small Clojure interpreter, in the to create these interactive notebooks. And I thought, wow, So if I might have had reservations about using an interpreted version of Clojure instead of actual JVM Clojure, but I figured, wow, if the interpreter is good enough for data science, and a Clojure computational notebook, then that's probably good enough for us. Then I recently found out that it's actually just used in the view functions, and not in the actual code blocks themselves. If you make a Clojure code block, it's real Clojure there, with the real JVM startup time, and that's good, actually, so that the entire language is available. But for here, it's more important to offer the user closer to instantaneous feedback for when they're working on their solution here. It's really nice if they can do this really fast without having to wait for it every time. Now, could we do something where, because unfortunately this leads to a lot of, we get a lot of people that are confused that their solution works locally, but then they go to submit it to the site and it doesn't, and we have to constantly explain that this uses an interpreted version of Clojure. And that is actually anyway, I was thinking maybe there would be some kind of way to, if the solution contains, see if it contains a Java method or something that is not supported by Babashka, then it could actually boot Clojure only if it's necessary. That would be a really cool thing to do, and it would be a nice compromise, because this is. We also started. I started working on a Babashka track, which is over here, and it's kind of abandoned at the moment. And the reason is, well, because we're using Babashka for the Clojure test runner. It doesn't actually make sense to me that there would be also a Babashka track. It seems we have a Clojure script track, which actually also uses the Node.js version of the small Clojure interpreter. And so that is that's also not exactly real Clojure script. It's just the Clojure interpreter running on Node. All right, so here I was needing to write a test runner, and without any clue how to do that. Okay, so here is, this is the current version, which I guess brings us to the whole point of this stream is to document the recent upgrade as the result of the contribution of Meridius. David Rollet was a student who went through the entire Clojure track and then said, "Hey, how can I give back and keep learning Clojure and by contributing to this site?" And so he must have I can't remember what was actually what were the issues that prompted him to work on the test runner. It must have been this: runtime errors and multiple assertions. This was the issue here. Errors and tests are not reported. Okay, he made this issue. If any unexpected runtime errors is thrown while executing a test, it is not being reported correctly. And this was the limitation of the runner that I had written. I had come up with something that that worked well enough, but and this whole time also I had been hugely curious what other Clojure programmers thought of, like how I did with my test runner. It seemed to work. We launched V3, and lots of people got to use it, and we only got minimal problems that were actually really fun to fix in real time afterwards. It was incredibly exciting. But it had some holes in it, and it was all around these nested assertions that certain exercises have. And yeah, so I ended up cutting some corners by not actually supporting the entire spec for Clojure.test. But rather a subset of it, which I then went through and edited all of the test suites for the exercises so that they all conformed to the test runner's expected input. And this was how I resolved the initial flood of issues that were coming in, where people having trouble with exercises that had the test assertions written in ways that I had not expected. I wrote the test runner to accept unit tests written in the way that I had written them for the concept exercises. But then when we launched the track, and it was also being used for the practice exercises, which I didn't realize can take one of many forms. And not only that, but when I made my sweep of the exercises to make all of the test suites conform, I missed some, which caused issues here and there to come in for people who are having trouble with those exercises. So this was not only the answer to exactly what I needed, which was someone else to bounce this stuff off of, because as much as I was able to step up to the plate and at least get something working. I was not the best person for the job, and I knew that the track was not as good as it could be as a result, and I didn't know where to ask for help either, because this is such a specific thing that was based on the constraints that were defined by the Exercism test runner spec. First of which was that the test assertions need to be reported in order, which was actually a problem for me, because the Clojure.test framework actually fundamentally works by randomizing the tests. That way you know that if the tests are ran in random order, that they're not passing because they just happen to be loaded in a certain order. And so that is usually what you want. But since what we're doing here is linking the users in the concept exercise, it actually makes more sense. We always want to show the code for the first test that's failing. And so I had to figure out how to deal with that. For a while, I used Clojure, which is a really great Clojure testing framework, produced by Lambda Island, and that worked great. But that's for Clojure, Clojure on the JVM, which we wanted to use Babashka, which comes with Babashka ships with a compatible version of Clojure.test, which I couldn't figure out how to get Clojure.test to report them in order. So I had to think of another way to do it. So I thought, well, let's just have a program that looks at the source file. In other words, parses the source code that makes up the unit tests, and just grabs a list of tests in the order that they're defined. So the way that the best way to parse Clojure code is using rewrite CLJ, and it one of the things actually holding me back from using it was that it uses these zipper data structures, which I had tried to use before for, I think, parsing XML, and it just I couldn't quite get the hang of it. And even after watching Arne's the Zen of tree shaping video, which was really great because it explaining the zippers, which turns out you have to go to the source, which is Hewitt zippers. And this is cited in the Clojure documentation of the Clojure.zip. Now, this is actually written, I think, in Haskell, or no, what's that? OCaml. Yeah, this is OCaml, and a zipper is a novel data structure that has a notion of a focus of attention called a location or a loc, and you can go up or down this data structure by navigating it in any direction. I'm not going to go through this here, but what I am going to do is show the Clojure.zip source code, because I had heard so many times that this is just something really great. It's a great use of metadata, because one of the features of the Clojure language is that you can attach arbitrary metadata to anything, and so this makes great use of that. But it wasn't until the day that I actually loaded this up and took a look at it that I actually realized, when they said to check out this code, they really said, no, do this now. So this is the zipper function that is the lower level function that is used by the rest of them, that just creates a zipper structure where you supply a predicate. So how do you know that tells you whether a given node is a branch, and the children, it takes the children, make node and root. Okay, here, so a children is a function that, given a branch node, returns a sequence of its children, and that depends on which data structure you're actually using. And make node is a function that, given an existing node and a sequence of children, returns a new branch node with the supplied children. So you supply a function that that will be appropriate for whatever you're using, and we'll see how it's used in a bit. And then root is the root node. So for nested sequences, so this calls zipper with the seek predicate, and that's how you would get the children of a sequence, is to call identity, and that is the function used to make the node, which just creates it creates the children while attaching metadata. And so here's one for vectors, here's one for XML. And these are the functions called by the node, the zipper API, node branch children. Okay, so that's for actually creating the nodes. Returns to get the left siblings, right siblings. Returns the loc of the leftmost child, and yeah, this is just this is absolutely wondrous library code implementing this zipper data structure. And I found it, when I tried it for parsing XML, I found it to be kind of unwieldy to work with. And it's only because I didn't really understand how to work with them. And Arne's Zen of tree shaping talk was really great, but the one that actually helped me do it, helped me understand it finally, was actually a project that I was given a little bit of credit for, and it was the Forever Clojure. The reboot of Clojure, which is the classic community set of coding problems for learning Clojure code, which was always at forclojure.com or .org, and then until it went down, and we needed to reboot it. And all right, so I was not available at the time. I didn't even have proper internet access. So unfortunately, by the time I had thought about making a web app, because I was contacted by Bork Dude, Michael Borkin, of the creator of Babashka, and he asked me about this. And when Bork Dude contacts you and asks you to do something, you take that seriously. And it was actually, one of these. I created the issue here, and just about immediately I found out that Oxalorg, what was his name? I can't remember. I need to remember his name to give him credit. He needs a shout out. How do I get to his profile? Mitesh. Yeah, it was actually his video right here. He documents actually taking the file that I had created that was powering this little web app, or not a web app, this was a command line app. I had, so the Clojure site was gone, and this is what I had put together by scraping their MongoDB database years ago for a little learning project. I wanted to see how hard it would be to get the Clojure site running locally. So I installed MongoDB. I think I did this all on my Raspberry Pi. And I connected to the Mongo database using Congo Mongo, which was the old way. And actually, this wasn't even complete. And so some contributions over the years actually made it complete, so that this served as the only existing data set containing all of the community problems. And unfortunately, there were just, let's see, what was needed here. It wasn't quite adequate, and so this...
Hey everyone, today I'm going to be working on an interesting problem. I'm not sure if you've heard, but forclojure.com is closing down, and I kind of started building this Forever Clojure, which is a completely static website, and I'm using the SCI interpreter by Bogdude, which evaluates the code in the browser itself. So this is pretty cool. There's one problem which I'm trying to solve, is that there's no difficulty level mentioned here. So if you've seen the original Clojure.com, you can see like they have this difficulty tag. But the data set which I got from another repo did not have that.
Wait, what did it not have?
Let's check the data from Clojure.com. You can see like they have this difficulty tag.
Yeah, I didn't add the
but
difficulties.
The data set which I got from another repo did not have that. Let's check the data set which I got from this repo, which is problems.clj. So I have this Clojure file with a problems map list of maps, right? And I kind of want to add these difficulty and maybe even the topics, right? Even if I can add the topics as well. So today I'm going to try and solve that. So let's go back to our GitHub repo, and fortunately Lawrence over here has scraped this page, and he's attached a really nice Excel sheet, a CSV sheet. Let's check that. Okay.
So someone scraped all of the difficulties.
Here, we have the difficulty here in this column. We've got the name of the problem, and fortunately we do have the URL as well. So we can kind of, I think we can kind of parse the IDs out of this. These are the ID numbers. We probably do.
Okay, so yeah, the problem was how to get these difficulties into the Clojure data set that I had created. And so he's showing how to do this using rewrite CLJ and Babashka.
The first thing I'm going to do is I'm going to copy the list.csv here in the Clojure project, and I also am going to launch Emacs, and I've created this bin/example script which is going to use Babashka. So let's actually go and launch a Babashka REPL. We've got a REPL on 33173 port, and let's connect localhost 173. We really need a cider back in Babashka, and I think we have our REPL connected. So let's test it out. Yep. Let's load some of these requires, and let's also load rewrite CLJ, right? Fortunately, Babashka already provides us, and we need the zip version. So I'll zip. And what we now need to do is we need to read the CSV file. So again, fortunately, Babashka already has a CSV alias. So let's do that. Let's open. Let's create a reader. Let's give it a file with.
Okay, so he's getting the loading the CSV file with the difficulty.
Data.csv into a map. CSV.
And converting that into
I want the ID, and his most of the tags
a Clojure data structure.
Use case port. Right, URL I want to do. Let's, but we also one extra thing. Let's do that. Want straight, so let's think function, right? Update string and empty string. Right. We've got the, I think we can okay, we've got this data passed with ID in the data.clj file, right? So I need it here. I kind of want to add this inside of these data. So let's look at using rewrite CLJ for this, right?
Okay, so this is the a video that actually helped me figure out how to use the zippers.
So rewrite CLJ kind of works with zippers, right? So zipper is a tuple, the first element is a tree and the second element is a pointer, a place in that tree. So let's create a zipper first. Let's read. Yep. There is an off file and there is an off string. Let's actually work with a string. Let's see this part. Let's just write a string manually here, and let's add like 2 elements to it. Let's add id1, let's id2. So let's actually check what is in zlog. So the zipper has this structure right now, okay?
Yeah, so just for that one little string, it produces this entire page of that's a data structure. And so it lists the children, first of all, which, so we have NS, which is the namespace. Then we have a space, which is white space, and then we have a node that is app.data, and then we have the left parent nodes. That's P nodes, is the parent nodes, and so this contains the children of that. And so, yeah, it's
we've got the first structure.
If you don't understand what you're supposed to do with that, then it's kind of overwhelming.
Maybe the file, the string, and where is NS? Okay, so the first child is value NS, the second is a white space, and the third is app.data. So we basically have the first NS app.data here, and then we've got this other nodes, right? The children nodes. So one of them says, okay, so this is the children which kind of goes in here. Let's not try to read the structure.
And that was actually what I needed to hear right there. He says, let's not try to read the structure. And that was actually what was holding me back from understanding zippers, is that I thought that I was supposed to understand and do something with all of this. And it turns out that you don't.
Instead, it's actually work on it.
You actually just work with it.
And let's go down one level. So let's do a zlog down, and let's also print the node. So
and that's important right there, to call node at the end, so that you get just the node at the location.
Let's see, what do we get? I do this
instead of the entire
or maybe if I just do
data structure.
This expression, get rid of the node. Okay, so the first zlog is the app.data. And if I go down and then do S expression, that's NS.
Yeah, and the S expression function at the end of the chain here takes the node and converts it into a regular S expression. In other words, the code, which is what you're interested in.
Okay,
and so really that was all that I needed to start working with this. And so what I think I'll do here is I have a WSL terminal here where I have a local copy of the Clojure test runner repository. And what I'll do is I'll load this in VS Code. Okay, so this is the Clojure test runner script, and I'm going to start a REPL using Babashka. So now we're connected. Yep, it did it instantly, and now we can work with this interactively. So I'll evaluate this form, which brings in all of these aliases that we're using. Now, for parsing JSON, for string manipulation, and rewrite CLJ.zip as Z. So that is our zipper source code parsing functions. This here is to support Clojure spec, which is a data validation and generative testing library that somebody wanted to use on Exercism, and so I figured out how to make a jar here with additional libraries in it, and then load them so that they are available. And so here we get when the test runner is run in production, it's passed the exercise name and the working directory as the first and second command line arguments. So this defines them there as slug and in directory, and then it defines the test namespace as well, it's whatever the exercise slug is, just with test appended to it, and then converted into a symbol. Now, this is the function from Babashka.class path, which is CP, to add to the class path the source and test directories from the student, from the solution that's currently being tested, and then the test namespace is required. So what we're going to do right now in development is actually define those to a test project that we have here. So let's say it's an example success. I'll copy this directory and it needs a trailing slash, and for in directory, oops, I'm going to define it as that. And slug is, I think it's leap, because that is the exercise namespace being tested here. Yeah, so the slug will be leap. So I'll define that and define that, and that defines the test namespace as leap test, and this will add them to the class path, and this will require the test namespace, and it returns nil, so that worked. And alright, so now we have the exercise test path. So here we're calling the zipper function that will take that file and turn it into a zipper with the location, in other words, the like the handle of the zipper, if you will, as the first node. In other words, the first piece of source code at the top of the file. And so this was the first thing that actually gave me a little bit of concern, is how long it actually took to just to define this and print it out, and how ridiculously long this structure is. That it had me thinking, is this even a viable thing? Is it going to take forever to do that? Using, I didn't have a lot of faith in how well these zippers were going to work for this test runner, to be honest. So now if I take zlock, well, that's going to print out the same thing, but what we want to do is set up a function chain here, like this. So we'll take zlock and then call z s expression, and that takes the first node that is currently the at the pointer and turns it into an s expression. In other words, so we get the line of code back, and it's the namespace declaration at the top of the file. And so the whole point of this is actually just to get the list of test assertions in the order that they're defined, which would be over here. Example success, test, leap test. Because, yeah, so when we finally received the contribution, which was this huge amount of work that David did, he took this test runner that I had written and actually made it really good, which is really amazing, because now I can honestly say that this piece of software is a genuine work of art. And I can say that without sounding self-serving, because it sure wasn't the way I had written it, but it is now. And during this stream, I'll hope to demonstrate why. But he said that he wondered why we were parsing code at all. This is a test runner. Why do we need to be worrying about nodes in the source code and navigating these zipper data structures? It's actually all just to get the list of tests. And that's one of the reasons why I decided this was really important to do this stream is because it doesn't say that anywhere in the documentation. You could look through the history of the GitHub history of the creation of the test runner, but some future civilization doing code archaeology would never know why this person decided to do this way. And so this is my opportunity to talk about all these things. I simply thought, okay, we'll have the program look at the code and we can find out whatever we want about it. And so here is a function that lets us know if a given node is a def test, and that just works like this. So if we passed a node So if we replaced loc with, say, zloc, that is the first node, is the NS. That's the first child of, if we go down the zipper, that goes down into this first list. So then the children become NS, white space, leap test, white space, and then here is another list. And then, well, so these are predicate functions that just give us information about the node that we're currently at in the zipper, whether it's a test, whether it's an assertion, in other words, an is, because it's each is that is connected to a certain task of the exercise. And that is considered one test, one assertion. This returns the name of the test, if it is a test. And to get all of the test code for a given test, well, would be just to return this. So here it gets all of the child expressions using the function of the zipper API. It takes all but the last two, and then joins them with new lines, so that it. Let's actually try that. So we will get a test. So there's our source code, and we would go to the right. In other words, to get the first child on the right, and then turn it into an S expression, and we get this def test form. All right, so what we actually want is the is form. So to get that, let's see, we'll have to go down, right? And that gives us, well, the def test symbol itself. So then we would go right again. And then that gives us year divisible by 4. Right again. And then we get the is assertion. So what I'll do is I'll define this as I'll define that as assertion, and I'll define test code here, and now we can go test code assertion. And that didn't, it says it's trying to cast a list to a function. So, yeah, because what we want is the node itself, not the S expression version of it. And, oh, interesting. That it doesn't have a, wait a minute. It could be that we actually want the def test. So this would be, we'll call this my test, so it won't clobber anything. And we're just going to go to the right once so that we will get, I believe that is the def test. All right, yeah, so that's how test code works. That gives us, so that's how the user knows what test was, what code was run, so they know how to debug their solution. Now, the way, this wasn't the way that I had written it. That's a smarter way, which is why this is so great, because what I am demonstrating here is the work of two people, one of which really knew what they were doing, which was not me, but at least he didn't just rewrite the entire thing. At least that wasn't the way to improve what I had written, not just to redo the entire thing and say, oh, now here's the way to do it. It was actually a good confirmation that I might have had the right idea. And when I saw these functions, which are just brilliant, well, a lot of it was like, oh, that was how I should have written it in the first place. A lot of these improvements were things that I had in mind to make the code simpler, but did not get around to actually executing. And I kind of knew that this is what I was going for, but my version was kind of a mess, like this logic for creating test results. This was a bunch of spaghetti that I had written because well, I hadn't broken down the logic. Instead, I just kind of wrangled the test results together. But these functions are so great, to get the test code, and to get the message, and to use those to generate the report, which is all taken from the test run, which uses the same Clojure.test, which is required here and aliased to T, and it's run right here with this run tests. However, this is important here, that we are overriding the Clojure.test print methods so that it does something kind of special, so that we can then use the results however we want. So this find assertions function is just wondrous, and it uses this subzip function, which is really important, which isolates the subtree to prevent find from leaving, so that we can use this find next depth first function in order to give us the next test assertion. And let's see, so why did this not resolve the symbol? I try to You know, it could be that there was an error somewhere else that actually caused our process to fail. Yeah, let's see what it. If I open up the terminal and I'll just kill the terminal actually. Let's start a fresh runtime, and what I need to do is go back through here. I will actually, yeah, we can leave those. That loads the test file code. Get rid of this. I'm just evaluating these as we go. And let's see if this works now. Yeah, cool. So yeah, this find assertions function is amazing, and this is way better than whatever I had. Let's take a quick look, actually, just to compare. That's the source code for Clojure.zip. So yeah, these are the functions that we're using right now, like next, previous, like when we go to the right, what actually happens? It returns the location of the right sibling of the node at this location, or nil. So it destructures the location, and it puts this metadata on it. And by way of the metadata, it keeps track of where we are. And all right, so we want the Clojure test runner, but we want to look at the version before David's contribution. So let's see, how do I just... Yeah, I guess this is fine. Okay, so this is actually the code that I wrote. And yeah, see, what this does is it's just a simple loop that is past a zipper from the head of the file, and it just finds each test. In other words, if it meets the predicate test, which is if the given node is a def test, then it puts it in the vector, and until we get to the end, and then it returns the vector. And then Well, that's all it does. It returns the a list of the def tests. And okay, so yeah, this one gets the names of the tests, and then test code gets the actual code of each of the tests by calling either test name or test code. And then this turns it into a map of the names to the codes. So yeah, that it's not that this was messy. It's actually just overly simplistic. It doesn't handle the various ways that the tests can be written, which let's show an example of the nested assertions, actually, to show what would have broken the test runner the way that I had it. So here's one way: flat multiple assertions would be something like this. So you have a def test that has 3 different is. And yeah, so since all we were doing is just grabbing each individual def test, we can't handle these individual assertions at all. If one of them was failing, the entire test would show up as failing, and there would be no way for the user to debug their solution. There could also be it gets even more complicated, and these are all completely valid ways of writing tests according to the Clojure.test spec, which actually follows the XUnit spec. Yeah, so you can have any combination of nested testing blocks, which is a way to add a description, or is assertions. And so we needed something smarter than what I had done, and this is what David came up with, this find assertions. And so we could take the path of one of these files, like say this example flat multiple assertions, and we will define that as the indirectory. Now I will kill the REPL connection here and start a new one. And so now we'll define this, and that loads it all up, and that parses the test file. And what I think is the reason why it actually took a couple of seconds at least to do that was, I believe, just parsing, preparing this text for printing, because in production it turns out it doesn't take that long, which was a really pleasant surprise, which actually proved to me that it would be an actual viable option using these zippers for the test runner. I had no idea that it would actually work so well. And That's even using the standard implementation of zippers, which doing this in a functional way with the metadata is actually quite slow. There's a library called FastZip that does it using in a more efficient way. But we didn't even need to use that. Also, it would need to be compatible with Babashka, which I'm not sure. So, find assertions. This would be called on, well, I believe a def test node. So let's find one. So we'll set up zlock, and we will go to the right, and whatever the node is, we'll turn it into an S expression. And yes, there. And what I'll do is comment this line out so that this is the def test node itself, and we'll say find assertions. And we can see that it works, so that it printed out a list of these is forms, even though, well, those were all under one def test. So previously, that wouldn't have worked, but it's all the magic of this this pipeline here. So we turn the location into a subzipper. In other words, to isolate the subtree. And I guess it's all the magic of this find next depth first function. And let's see. Let's take this and follow its execution to so this here I'll define it as my test, and I'll put that here. All right, so now what I can do is comment these steps out so that we can see what each one does. Oh, let's see, that's all right, so that is the result of calling find next depth first and iterating on it. Now we get all of these nils. Because those were nodes that did not contain assertions. Assertion is the predicate for what we're searching for. So REST just actually gives us everything but the first one, because apparently the first one is irrelevant. And a take while sum actually gets rid of all of the nils. It takes while not nil. And so here, well, we're using iterate to go up the tree and take each one while that is a test. So yeah, this is a function that we're mapping over the result of this, which is all of the assertions, and each time it goes back up and grabs the def test and then turns it into an S expression. So and then they're turned into strings, but actually there is a string function that actually we could just use that instead of S expression, and that would we didn't map them. Okay. Complement test. Okay, so it takes them as long as it is not a test. Complement reverses the logical truth value. So that was a huge improvement, and it's a great demonstration of how to use the functions in the Zipper API to search through source code. So that will come in handy for all sorts of stuff. Now, this was also a really great function that abstracts the traversing of the zipper into something that we can use for all of these. So I had repeated this logic for each of these functions. Instead, we just use for each test, grabs the test name, grabs the test code, test assertions, finds all the assertions, and these are actually not functions, they are variables to store a vector of the result of doing those for each of the tests in the test file. And we create our test code map and our test assertions map. So yeah, there we have it. A bulletproof system for getting all of the assertions written by Meridius. So then, these are atoms which are used to store the results of running the test runner, so that we can keep track of the passes, the fails and errors, and the assertion counts. This was a great addition. It tracks which assertion is being reported on. That's necessary so that we know which one we're dealing with. So that it has to count them. So here we keep track of the assertion counts. Cool. So this extracts the error message using X data to get the exception data. And this for reporting the errors. That was new. And all right, so get test code. So when a test fails, we need to show it to the user on the website. And if it's a passing test, we just show the entire thing. But if it's a failing test, we want just the assertion that failed, or the whole test if the index is out of bounds. So this get function will actually test assertions map. So yeah, how does it uses the not found arity of the get function. That's great. I've never even used that. So yeah, if you get takes a data structure, an index, and then a not found, an optional not found argument. And the reporting function, which gets the test code and just merges it into the first list of testing vars that is put together here. And so, yeah, here is the, this is actually how our reporting system works. So that when we run the tests, we're hijacking the reporting methods here. So that normally it would display something, like testing, whatever the namespace is. And here we're just overriding it so that it just does nothing. It just eliminates that step. And for the passing tests, well, instead of reporting the normal way, which just prints it to the console, it swaps the passes into our atom here. By adding whatever the test report of the passing test is here. And the same with the failures and the errors for the fail report and the error report method. And summary, we're also just turning into a no-op. And here it's processed into a JSON map according to the version 2 spec of the Exercism test runner spec. So yeah, failing tests are listed first. Okay, so that's the way I should have written the test runner. However, we didn't know if any of these improvements made might have broken something. And so we had to, how do we know that these improvements and new functions are sound and that we can confidently merge them? What we're using to test the test runner here, this was put together by Eric. in a similar fashion to other tracks on Exercism, where we have a bunch of example solutions. So this takes the leap exercise, which is just a typical exercise, and tests them using various conditions here. Like we were testing the success one, which is all passing tests. Here we have one that's all fail, where we have source code that will fail. Then we have a partial fail, we have an empty file, we have code that will cause a runtime error. But what we really wanted to know was how this is going to handle the various test suites used by the exercises, in particular the practice exercises in the Clojure track. And I purposely did not tell him about the script that we had currently running in CI, because, well, when this pull request came in, and I was immediately floored, because it was the first time that I had ever even gotten the feedback from someone about who could tell me anything about the thing that I had written. You know, how does this even make any sense? And to be honest, as fun as it is, being treated like the resident Clojure expert here at Exercism, it's just it's been a little bit difficult living up to that, because even though I've been doing this for 5 years, compared to my peers, I'm just a baby. The average Clojure developer has 10 years of experience, which that's pretty incredible. It's great to be in the company of such smart people. But if you want to do anything that to get noticed, it's going to have to be good, because you're going to have lots of competition. And so, yeah, actually, the biggest pain point for me working on the Clojure track at Exercism has been that I am the one with the most Clojure knowledge. So, yeah, and that is, well, not a problem, but it got kind of lonely, and not having anyone to, or not knowing where to get feedback on this thing was really holding us back. And so when this came in, it was suddenly made my life all of a sudden, well, it filled in a gap that was had long been a pain point. And so here I was looking at a detailed explanation of the deficiencies and this person figured this all out. Only the name is saved and not the error message. So I was not handling error reporting at all. And unlike pass-fail, the errors atom just stores a vector of strings, but then I was actually doing something that didn't quite make sense, that wasn't making the errors retrievable. And here we go, the big one. When a test has multiple assertions, it calls report multiple times, but then clobbers the test because it's the same test name. That's the problem. And so by creating the assertion counter, that way we can append a number to each one of the error messages or the test names, so that they have unique names, so then we can refer to them. And I greatly enjoyed going through all the Clojure exercises via the web editor, so I'm more than happy to give back. And, well, they got it working. So that it reports the error properly. Yeah, the assertion counter. I was under pressure to do something fast to get the exercises working that didn't conform, that were breaking the test runner. And so I just went through, kind of in a panic, doing damage control and attempted to just get rid of all of the nested assertions. That's what I did here. I made a sweep where I made the test suites conform to the test runner expected input. So this was just a something that I did just as a quick hack, because it was the best thing that I could think of. Actually, first I tried some other stuff, which was really crazy. I tried making a recursive evaluator that would use smarter logic in order to get the individual assertions. And the thing is that this actually got so complicated that I eventually just had to abandon it because it was just not realistic. And it still was just it was interesting because at this point, when I made this version of the test runner using this recursive evaluator, at that point all we were using Clojure.test for was to run the individual assertions. And I realized that what I was doing was actually just repeating a lot of the logic that was done by Clojure.test already, unnecessarily. And so I realized it was just not the way to do it. So instead I went through and made all the test suites, and I was okay with that, so I thought, because I figured, okay, well, we're just using a more constrained spec, as opposed to the full Clojure.test range of ways that unit tests can be written. And so as long as it's known to everyone that is contributing to unit tests of the Clojure track that the unit tests need to be written in a way that is supported by our test runner. But these were all exercises that I missed. And so when this came in, I verified that all of the practice and concept exercise unit tests in the track itself still pass with their example solutions using this updated test runner. And they said, oh cool, I wanted to do something similar, but I wasn't sure how. How do you do that? Maybe we should copy them all into this repo's tests folder with a bash script to sync changes in the future so that we make sure that we always test them. And I never got back to them about that because the thing that I used to in order to do that verification was something that I was not comfortable sharing, and it was this here, which is what is currently running in CI for to verify all of the exercises on the Clojure track. So I am actually proud that I did this because, well, it was taking the advice that I heard from Sean Corfield, who is an expert Clojure architect, and he was talking about all of the refinements that have been made at his work over the years, and how they have just increased their productivity immensely, working with their Clojure code base. And he said that he owes the most significant productivity improvements not even to the choice of languages or other technologies used at the company, but rather for putting a lot of work into a good system for continuous integration. By having a workflow that verifies your system, it allows you to develop more rapidly and more confidently, and in such a way that will enable future productivity more than anyway. I thought this was incredible advice, and so I thought that this was an issue on the Clojure test runner repo to make or it might have been here actually, to make a CI system add CI. Yeah, I think this was it here. So yeah, I decided, even though I could, well, maybe because I was still suffering from long COVID cognitive effects, and so, yeah, I needed the additional confidence that would be enabled by creating a robust verification system. To remove the mental overhead created when you're maintaining a track and accepting contributions, large or small. The sustainability of the project, it's pretty clear, pretty hard to it's easy to see how investing in this was going to be probably the best way I could spend my time. So I modified several of the example files to make them all compatible with the test runner, which runs under Babashka, which was made possible. It was using the work that I had done porting the Clojure exercises to the Babashka track. So even though I kind of abandoned that, it came in handy for this, to create the CI workflow. And to pave the way for this, we needed to make a GitHub Actions workflow. And to test it with the Exercism Clojure test runner Docker image, as you then have a proper integration test. And so I had never done any of this stuff before. I had never used GitHub Actions. I had just barely learned to use Docker to create this tooling. And Docker broke my computer. Well, it actually just kind of revealed how my computer revealed that I needed a new computer because I needed to use Docker. So I had to get a new machine, and so then I started working on this. So I had to learn enough YAML to write test YAML that fetches this repo and the Clojure test runner repo. It does this in parallel so that each repo has its own path that is accessible in the Docker image, and then it builds it and runs the tests. But that's not quite what we want. Okay, so yeah, this was me figuring out how to do this. So I figured out how to run the tests in the Clojure test runner repo. And then I had the test script in the Clojure repo that is also not actually an integration test. And so I had to figure out how to wire them together the right way. And I could tell that it was working because it was reporting errors that didn't go, so the new workflow actually wouldn't pass until I fixed some errors that were in an exercise. So yeah, this was actually one of the hardest things that I had to figure out was how to download two repositories in parallel. And I probably looked at the JavaScript test runner or something to see how it did it, and that's probably how. And I also had to read the GitHub Actions documentation, which was really good, and figure out how to actually build Babashka in the container for the GitHub action. So I used this library here, this Babashka Docker action, but this has actually been replaced by another GitHub action that's been actually selected by the community as the one to to support moving forward. And yeah, the other one actually works a little bit easier. We just get a command to run so that we can actually supply the arguments the right way. This way, actually, just we have to supply a script, and I'm not sure if it actually supports arguments, which is important because we need to pass the exercise slug and the path of the in directory when the test runner is invoked. So then, yeah, here we have, let's see, what we need is, I'm trying to find test CLJ here. So this is the script that I wrote that I wasn't comfortable sharing because actually when I was trying to get it together, it was giving me problems that I wasn't exactly sure to resolve. Like, yeah, these functions are just really messy. There's just all of this yucky repetition, because it's slightly different. If it's an example from a practice exercise or a concept exercises, the paths are different. And for the concept exercises, it's called exemplar, where with the practice exercise, it's example. So I had to have separate functions for dealing with the practice exercise, seeing if it passed, copying the example and replacing it, which actually just shells out to MV, which is kind of a cheesy way to copy a file. And then it checks them all and then reports the results, says how many were tested and how many fails. And so, yeah, this is what is currently running in CI. But since I did not tell David about that forced him to write his own thing, which actually he did such a great job with that it actually puts my version to shame. And I'm actually more excited about this than the improvements that he made to the test runner itself. So we'll take a look at this right now. So this is the testing system that he created for verifying the test runner. And let's see, it's in, I guess it's in bin, run exercise tests. So this is great. This is a CLI. It's a CLI script, which is put together using Clojure tools.cli in order to parse the command line options, so that it creates results snapshots. The way it does that, let's see what actually update snapshot takes a snapshot file, how does it actually get the snapshots? That's what they're in. Well, they're in the results snapshots folder, but then let's see, when they're updated, this is the Clojure repo, the local version here. So yeah, we have results snapshots. So this is for so the big improvement made here is that he realized that one big limitation of our current CI workflow is that it's actually only checking all of these exercises after they are solved. And it does that by just copying the example or exemplar file, the contents, into the source code file, which is initially contains stubs. And so it copies all of them. Makes kind of a mess in the process, to be perfectly honest, because I wasn't even using a temporary directory, which would have been a good way to do it. And then it tests all the exercises. So a big improvement here is that it tests each exercise twice. First, just the empty source file. Well, it's not empty. It contains stubs of the functions as unsolved. And then it applies the solution and compares it to the results after they are solved. But what I'm trying to show here is, well, this snapshot system is just wondrous. And I want to understand how this works a little bit better. And before what we're going to do is, and before the end of this stream, if I don't actually get to this, we'll at least create an issue explaining what needs to be done to upgrade the current CI workflow to use this. And it is in bin run exercise tests. So the results snapshots folder, when it updates them, what does it actually do? That's the question. There's a snapshot file. What is that? Update snapshot. So this, okay, yeah, that takes the snapshot file. But what is the, let's see, compare snapshot. Okay, so it comes from the snapshot path. Yeah, which is the folder called results snapshots. And so that's the snapshot file, is just the directory. Then what is the results file? The results file is the results JSON. So this is for each exercise. So when it updates the snapshot, what calls update? Okay, so yeah, if that option is provided by the CLI, then the update key is in the options map, and if so, then it calls update snapshot by providing the snapshot path for the exercise. And okay, so. And whether it's solved or unsolved. Okay, so updating the snapshot involves running the test and then replacing the snapshot files with the results that are created when the test is run. So yeah, that's cool. So and yeah, this run all tests function. This is what contains the main logic for testing the exercises. So we create a temporary directory, and this isn't shelling out to MV like I did. This is dealing with the file system the proper way, which is to use the Babashka.process library, which is actually it's a Babashka compatible version of the Clojure FS library, which is currently maintained by CLJ Commons. And those are, well, our solidified effective ways to do all the file system operations from Clojure or Babashka, which we're currently running. So we create a temporary directory, which with the prefix Exercism Clojure, followed by whatever the exercise is, and we get the list of exercises, and for each one we copy the exercise to the temporary directory. Now, T1 is going to store the results of checking each of the tests with the unsolved solution that is well, the source code file that ships with the exercise. Then we apply the solution by using a special version of CP. We have a CP function which takes a source and a destination and optional options, prints to the console that it's copying the file, and we see if it's a directory, then it copies the entire tree, and if it's a file, then it copies, well, it just copies, and then cool. So they wrote a better CP. And so we were, so it applies the solution by copying the example to the source subpath and sets replace existing to true. And then, we run check test again, which accepts as its third argument true or false whether the exercise is solved or not. And so T1 is the results for unsolved, and T2 is the results for solved. And here we create the aggregate results. For each one of the exercises returned, it creates a map with the total of 2 tests for each exercise, the number of passes and the number of fails, which the number of passes are just T1 and T2 added together because each one of those calls check test, which returns an integer. It's a 1 if it passed, and otherwise it's 0. And if fail fast is selected, then it just exits after the first fail. And so check test returns an integer, which we just add them together to get the number of passes, or we subtract them from 2 to get the number of fails. I had to think about this for a while until I realized how that actually works. And then, we pass the entire sequence of these to reduce, which adds the arguments together and in order to create our final report with the number of total tests, passes, and fails. And so this snapshot system is really that's how we can deal with the issue of the results of the exercise tests being out of date. And so whenever we need to create new snapshot files, we just run it with update to update all the results and snapshots. And so I think we have analyzed this well enough to know what we need to do in order to apply it to use it to upgrade the current CI workflow. So the way that let's see. It even has he even wrote instructions for using this to test the exercises locally. And that is, let's see. To test against the full Clojure track and compare with the results snapshots. So first we would clone the main Clojure repo, and then run this from this repo. And it defaults to, it will go up a directory and find the Clojure directory. So actually, yeah, this will drop right into our, it'll be a drop-in replacement for our CI script, and provide a way for anyone to clone the Clojure repository and test all the exercises on their machine. And so I have, so I've done this already. That's my Windows one. Actually, what I want is the WSL one. Yeah, so if we go back here, we'll see I have the Clojure repository. And so what I'll do now is actually try the command that is given here. To run his test script, and if we'll just run that by itself, and it'll default to, and now it's working. It's testing all of the exercises as they currently were, which I think I recently did a git pull. So I think this is the current state of the Exercism exercises. And so the snapshot files, well, they contain the expected results for both solved and unsolved exercise tests. And so we would just need to run update whenever we change the exercises or the test runner. So this has 3 failing tests, which is interesting. Now if we append the F option for fail fast, it'll tell us, well, it'll stop after the first one that fails. So then we can figure out what's going on, actually, because this will already shine light on something that we were not yet aware of because it wasn't caught by my script. By the way, let's see, while that is running, we'll take a look at the current CI status is passing. That shows the badge on the home page of the repo next to the configlet badge. And, well, we can take a look at the workflow. Let's see, this is the... it was failing, actually, and I was going to have to debug that at some point. I got a message from Eric, and he wondered how he could help, and I didn't know. I said I need to get to the point where I can check it out. And I told him that this was what I wanted to do. But in the meantime, somebody fixed whatever the problem was that was causing CI to fail. It was fixed by this here. Fixes build, pig Latin, and this is the kind of stuff that this is what I deal with. So the headline for this stream is, this is important right now, a day in the life of an Exercism language track maintainer. So, yeah, have you ever wondered what it's like to be a maintainer of a, sort of popular track on Exercism? It's not wildly popular like JavaScript or Python, but it's more popular than I think any of the other JVM languages, including maybe Java. So, yeah, this is I'll just give you the most recent example. So I wake up just thinking that this is going to be a normal day, and I check my email, and there's a pull request. Someone has contributed to the Clojure track on Exercism, and it requires my attention. Okay, whatever I thought I was doing this day, just immediately, everything changes. And I have to put on my maintainer hat and my code review hat. And, okay, I look at the files changed. And this person has submitted a typo correction. This used to say single line comments, but single line is actually should have a hyphen because that's the descriptor. It's either a single line comment or a multi-line comment. So indeed, that indeed is a typo. So I put in my review that I approved it, and as a maintainer, you have to think about all of these crazy things. Like, is this contribution that this person is making, are they going to feel attached to this, like emotionally? I have to consider, maybe the job of a maintainer is not to simply accept every contribution that comes in. But anyway, you can see what I'm doing here. A lot of the contributions that we get are indeed easy reviews like this, but sometimes they are more like this. Where it is effectively giving a facelift to the entire track tooling, fixing all of the problems that I had not figured out and had swept under the rug. And did all of the code cleanup that I probably meant to do, but hadn't gotten around to it. And because I was embarrassed to share with them my testing script, that you would think that maybe it would have been it would have been very smart of me to do that if I had planned for that to happen. But I didn't know that he was going to do this, and effectively write a better CI script. So there we have it. Yes, a day in the life of a track maintainer. But okay, so here is our first failing test is Robot Simulator. What we need to do is find out why this is failing. So first, let's go to that exercise. How about that? And see what we're dealing with. We'll see if this is one. I have not solved this one yet. And the tests. Okay, so these test assertions have let blocks in them. That okay, so we are handling those, I believe, because the way that the test runner with the latest upgrades, the way that it does the finding the assertions logic, will actually just do a depth first search for the is blocks, and so it'll skip over those. So that should all work. He did a great job of actually figuring out how to do this, to handle all of these nested assertions. But okay, so what is the problem? It might be with this actually here. So this is an interesting problem actually, because we're supplying here a robot named Robbie, because I think it's a stateful test, and that's probably what is causing the problem. The Clojure repo actually has an open issue that's from before I got here. Eliminate implementation specific tests. Yeah. So, yeah, since Clojure is a functional language, it's not purely functional like Haskell. It's what we like to call a practical language. However, we very much appreciate testing pure functions with pure functions in our unit tests, rather than relying on underlying implementation details for mutable state. And I kept this issue when I assumed the mantle of the only maintainer was when I finally took the cue to go through the issues and triage them, because there was about 50 of them that were just old. Some of them were 8 years old, talking about things that were totally irrelevant. Like, this was back when the Clojure track was originally, when the practice exercises were ported from the other exercises, and so I went through and cleaned out the issues using, my judgment, because at this point I had committed to kind of being the one to guide the track forward, and that meant seeing what suggestions that had already been made were worth keeping or not. And this was As you can see, it's the one of them that I kept, because that seems like really good advice, and actually, as evidenced by what's happening now, is that we have a problem that involves mutable state, and how to test that is a question. And the way that this does it is it creates an example implementation of a robot. Where did oh yeah, we were sorry, I'm probably making people dizzy with these tab switching. So yeah, a robot I guess starts at, does this use something random maybe? Yeah, so this defines an example implementation and then tests against that. So let's find the example solution. So that would be and exercises, practice, robot simulator. All right, so this is the example solution. Alright, so I'll copy that and we'll paste that in here and see if it works. And it does, and that makes sense because CI is currently passing, which means that must have been tested on the last change to the code base. So why is it failing here is the question. Let's see. Well, we'll run it with the file as it is, and this is the results of running an unsolved exercise. Returns this arity exception, which is what we got here. This should show us the diff, actually. And status should be fail, but instead it was error. Well, it should be error, because it does indeed throw an error. So it could be actually that that we're going to have to expand the we might have to do something to the code here in order to give it the notion of errors. Test failed. Status should be, but instead it was. So, yeah, let's look at the results file for that exercise. There is no, it didn't create a snapshot file for unsolved because the test never successfully completed. Okay. I'm actually kind of surprised that is, that I guess that's probably the same issue with the other two failing exercises. Is they probably also resulted in an error, specifically an assertion error. Because we're trying to call robot simulator with 0 arguments. So we could fix this actually by modifying the stub file. Yeah, that actually might be the way to go. So what we would do, so that we would no longer be trying to call it with 0 arguments, we could just call it with it's the test file that needs to, wait a minute. We're calling robot with 0 args here, right? Anyway, I was thinking that all of this could actually be done after we hook up the new CI. Rather than before, because this is all stuff that we will need to do to make the CI pass afterwards. So what I could move into now is actually how we can plug this in and test it first of all. So what I want to do, since we can't do this locally on my machine because we need to set up a GitHub Actions workflow. So instead we're going to fork this over to my username. And we need to enable the workflow. So that's here in the Actions tab. So we have test, and so it might actually be in the settings. Actions. Allow all actions and reusable workflows. Okay, so I guess we're probably good. So what we could do now is, okay, so this, where is the workflow? Let's see. Test. Let's see if we can just run it somewhere. Alright, so it runs on each push, so let's make a little change, and this is the file that we're actually going to be replacing. Alright, so I'll make just a small edit to this. I'll touch the file just to force it to run. Oh yeah, I thought I remembered something about having to approve the workflows after forking a repository with actions. And okay, so it looks like it's running. Oh, and it's already failing. Why would it be failing? That's cannot run program, no such file. Test runner CLJ. Okay, it's looking for it in, I think that's the right place, where the GitHub Actions container is. It's having trouble running the test runner script right here. Which I'm not sure why. If we go into, we can take a look at the test YAML workflow. So it checks out this repo and gives it the path Clojure, and it checks out the Exercism test runner repo with the path Clojure test runner, because that is how we would achieve a proper integration test. However, that is not what we are currently doing, unfortunately, probably because of this problem that I still have to figure out. So it runs the test script and gets the output. All right, so that's all fine. So this is the script that runs. And we're grabbing the current working directory and appending it with /Clojure in order to point the script to the root. But I think that is not correct. Actually, we probably just want the root without the and then for the test runner directory, well, we want this directory then up one and into Clojure test runner. Does that work like that? Let's see. We will try it. All right, so that failed again already. And, oh, well, it's different. Oh, because I messed up the... I put an extra parenthesis there. Okay. And yeah, by the way, if someone knows a better way of testing GitHub Actions workflows, other than just by doing this by trial and error on the site, because I don't know any other way to do this, but at times it seems a bit inefficient, you could say. All right, so this is also a okay. Now we can see what it's doing here. I just need to append a trailing slash is all. Yeah, so, and you know, there's a better way of doing this by using the FS library. So, you know, maybe I shouldn't even bother with this. And instead, what I'm going to do is grab David's work here in the bin run exercise test, and I'm just going to copy this entire file. And replace this. All right, so now it doesn't make as much. Well, yeah, actually, we'll leave the CLI options because this will be able to use the same script. Well, anyone can use it to test the exercises locally. And yeah, as we can see, this is the proper way to deal with paths. Is we use the path function and apply and call that on a segment of a path, and then we use the normalize function to make it to to make it so that it works in a cross-platform way. The whole reason I'm using WSL right now is so that I can simulate a Linux environment on my Windows machine, and it's all to deal with the oddities around the path. So this will eliminate any confusion that would be run into Windows users that would want to test these exercises locally. So we'll assume that the snapshots are up to date, first of all. And all right, so this is going to run all the tests and print the results, and then exit with the error code. If there's any failures, it will exit with that number, so it'll exit non-zero. So yeah, let's commit this and just see what happens. So now that script is being run by the GitHub action. And it's still running. That's a good sign. And exited with an error. File not found. Okay, config JSON. All right, so why is it not fine? Oh, look, there's 3 closures. Clojure, Clojure, Clojure. There's actually just supposed to be 2. So where it's looking for that, we'll find out why there's an extra closure there. Since we didn't provide a Clojure repo path, this will return nil, which means it will use this, which goes back to the parent directory and then into Clojure. So maybe we should actually not or we could actually append the proper path to the call in the workflow. Actually, that's probably a better idea. So we can edit the command here. So we will run bb Clojure. That's the problem, because it's looking at it in Clojure. Wait, no, that's correct. That's just the name of the script, the location of the script, and we'll provide the path, which will just be ... right? The location of, well, it's this, it's just wherever we are. Okay, let's see what this is doing now. Okay, it's looking at it just in the... there are supposed to be 3 closures. Oh, okay, yeah. No, actually, that seems like that is right. Let's just include this full path. How about that? I'll copy that, and we'll just use the absolute path in the workflow. Let's see if that works. Okay, so the location of Clojure repository is that. Okay, it's running the script. Oh, I saw some red. Let's see. Cannot run program. Oh, that's good. It's something different. Okay. All right, because that's looking at it in the wrong place. Or it's looking for run.sh. Why is it looking for run.sh? That's it's looking for run.sh. Why? Because, let's see. Okay. Yeah, so this is calling run.sh in order to, let's see what it's doing. So there's the run script. Okay, so it uses that to run the test. Okay, so that that's what threw me off, because this was only used actually in the unit tests for the Clojure test runner project, the Clojure test runners built-in unit tests that Eric made. But no, actually, this is the script that indeed runs the test runner. And apparently it's not here. And that is true. Okay, so let's add it. Let's see, am I going to need to make this executable? Yeah, I think and I don't know how to do that actually on GitHub. So, okay, interesting. What I'll have to do is clone this. Wait, no. And this will be fine to do on my Windows machine, just in native Windows. So I'll just clone it using GitHub Desktop. I'll contribute to the parent project, and we will just show it in Explorer. That's fine. All right, so here we have bin, and so what I'll do is actually I can just upload the file. And that way it'll still be executable. Okay, so that was in Documents, GitHub. Was it Exercism? Clojure? I forget. No. Wait a minute. Oh, it's in Meridius Clojure. Okay. Oh, wait a minute. Where is the it's in the test runner repo. Okay, yeah. Okay, so we'll grab that from the GitHub directory, Clojure test runner, and it will go, let's see, we need, yeah, this one. Okay, run.sh. Okay, so now that is there. And alright, so well, it's still not finding it, which, let's see. It might be looking in the wrong place. Yeah, this should be Clojure / bin. Okay, let's see what's going on there. All right, so where we have the path, to the Clojure repo path is in the options string, where we found it. We use it to find the config JSON. So, right, that's it's getting that far, right? And yeah, so the path to the run script will need to be edited so that it will actually use the same path as the current Clojure repo path. So the way to find that is with this. So instead of run script, like that? Is that how it works? And Clojure repo path is part of the, yeah. All right, so let's see how this one goes. It's always good when it hasn't finished yet. Oh, I saw something fail. Oh, permission denied. Oh, because it still needs to be set to executable. Oh, that's annoying. All right, well, at least it found it. Okay, so how do I do this? I will clone this. I'll clone it in Linux. Actually, it's already, wait a minute. Okay, so now let's see, we'll do change mode plus X, then run sh, and then git push. Well, now we need to add it. All right. Okay, so now, oh, that's interesting. What is bash/r? That is weird. I have no idea what this is. User bin env bash r. I have no idea what I'm looking at. I have no idea what that bash R thing is. Okay, so it's having trouble checking this process. Let's try running this locally and so here is the file which we can play around with. So is this connected? Let's see. This is so we can use camel snake kebab. Okay, and we don't need the CLI options. Actually, yeah, we do. Okay, so our default options map. Now, actually, we need to change this. So let's take a look. So the default Clojure repo path is this, but what we need to do is replace it with the one that is passed in by the GitHub action workflow. So this here is the path. Now that should actually be available as the working directory. So it's this. This is where it says it's failing. Check. What is the check function? Yeah, like what does this check come from? Is that check and process. Now what, oh, those are from Babashka.process. Okay. Let's see what those do. Because, yeah, that might be, let's see. The function check takes a process, waits for it to finish, and returns it. And yeah, so I need to actually fully understand what that is doing and why this is here. So it's checking the process and inherit. Okay, so that's during the updating of the snapshots. Oh, and yeah, which we weren't actually using that, but we were using it here. So it's checking on the run script and somehow losing something. Now, you know, that is quite a cryptic error message. That, yeah, actually, that's why I need to try running it from here so that I can figure out what might be going on. So we have the run script. And I'm looking to see if there's a better way to get the current path. I think just using CWD is probably okay. So why is this taking? Okay, file is, well, the current file that the file that we're in, this run exercise tests. Okay, so then it's going up to, which is why does it go up to? That's it seems like it should just go up 1. Because if we're currently in the bin directory, maybe that's the problem. But why would it be? Yeah, because we're in the Clojure test runner repo. So then we would need to go back out of that and then, or no. So the Clojure repo path. What we actually want is the Clojure test runner repo path. And that actually kind of brings us to another loose end that was here. Because it's not actually using the test runner repo like it's supposed to, because it's using the one from this repo. In other words, this test runner, which is a patch. That's actually just a temporary patch that I made because I couldn't figure this stuff out, and so I just wanted if I couldn't figure out how to get the true integration test working, I thought it would be better to at least have some CI, and so I made a PR that was a patch that provided a local copy of the test runner script, and that indeed is the one being called by this. Except this is no longer the script that I had written. But that might be the root of the problem, actually. Let's back up to the GitHub workflow. So it checks out the test runner. And it runs the test script. Which used to call the test runner in this directory. But what we needed to do now is this run script that it's calling, we actually are going to need to modify. Because this is the script that calls the test runner, and here it looks at in the home directory, where it actually needs to go. Let's edit this file. It needs to go up one, and then to Clojure test runner. And that should work, I think. Now it's giving me this same thing again. What is bash wrong/r? Is that like a carriage return? Why would it be? So this is it's an error from Process Builder. So let's see if we can figure out what's going on. It shouldn't, okay, yeah, that's fine. Exercism, Clojure. We probably need to change the run script, maybe. This is precisely why I hadn't gotten the continuous integration to where it should be, because I don't really know what I'm doing here. And there's just so many things that okay, so this here, I think maybe it's not finding the run script, because that is not the run script is actually in the Clojure test runner repo path, which might actually be the problem. So if you go to the Clojure repo path, well, I guess we could just maybe do, is that how it worked before? It had, let's find the, just the absolute path and just try to use that. So it would be this. Except Clojure test runner. Maybe. Huh. Okay, here we go. Oh, look at that. It's actually testing them now. That's new. Could be maybe I figured. Cool. So okay. I think it's actually working now, and it's telling us that. Well, let's see. No, these are. Okay, line 37, the test runner CLJ. We need to change the run script so that it includes the proper path there. But yeah, I think we're getting somewhere. Yeah, so when we run this, we need to just hard code this. Am I editing this file? No. Okay. Alright, so here's the real path to the Clojure test runner. I think there's just supposed to be, yeah, wait. Yeah, it's Clojure test runner. Yeah. Now the thing is we can't modify that. We obviously can't modify the run script that's in. Oh, but we're not actually. That's we'll be making a new run script. Let's see. So this is wrong, actually. Wait. Yeah, because yeah, that makes sense. Or does it? So at this point. At this point, it has downloaded the Clojure test runner repo onto the path. So yeah, it actually. But then, at that point, it's running, and it should find it here, shouldn't it? Wow. See, this is confusing. Because then, then it can't find this. But why? All right, that's how zippers. Okay, that was oxalogs. That was that. That's a day in the life. Okay, there's Babashka.process. Okay, that's the zippers paper. All right, so when it runs this, well, it should be there. But let's see. It must be that at that point, it's running the other run file. Yeah, I think the run script, I think we want to use this one. Yeah, and that will be, that might fix the problem. Yeah, okay. So let's see, so where is it creating these temporary directories? That might be... So it's when it's trying to copy... I might have to actually enlist the help of someone who knows more about this stuff than I. All right, so where it's messing up is this check process, which is being called it's being called here, I think. So, yeah, this might be actually the problem. So the path of the run script is the process that is being checked. And let's see what that does for a second. Now, I need to find out what this run script slug path. Like, why is path repeated? It must have something to do with the way that this works. This check procedure, or check process inherit. So let's look at Babashka.process. Okay, so yeah, we're setting the process environment. Okay, yeah, so we probably need to modify one of these paths. Okay, what are the arguments to process? That's process previous command options. Okay, so it's calling process with the arguments with 3 arguments. So it was the one interesting. Run script slug path. Okay, so yeah, it runs the run script with those arguments. Okay. It could be we just need to prefix the path with the Clojure repo path. Yeah, that's an idea. So if we grab this from here, so that's correct. But when we run the test, okay, so the test directory. When it's created here, we need to make sure that it's created where we want it to be. So let's see the documentation for create temp directory in Babashka.process. I think okay, so we have API docs. And so create a temporary directory using files, create directories, okay. Does not create parents, okay. So yeah, it looks like it just, it's not taking a path here, which actually might be so yeah, it looks like all we need to do is just pass an option map. We can just supply the path as an option, it looks like. So here, where this says prefix, we'll have another key that says path. And we're going to want it to go that's the path that we want. And what I could do is actually save that as the absolute path, but yeah, well, first of all, let's see if this works, or see if it does anything different. Yeah, it's doing kind of the same thing, actually. Bash R. Now, what does that mean? It's looking for bash with... that looks like it... It looks like it's being caused by something weird, like... it's in the run script is where it's having trouble. It's as if there's like it's trying to load something other than bash, like I don't know. Let's see. So how can I debug this? It would be nice to actually avoid using this run script. The only thing we're actually using it for is to format it with JQ. It could be we need to change the input or output directories that are being called by that. So let's see. There's the test output path. But if we look at where the run script is being called from here, so yeah, why wouldn't it be able to run that? Let's, All right, here what I think I'm going to do is I'm going to simulate the actions environment locally. It seems to be so here's what I'll do. I'll create a new directory here called CI test. Oh, I already have one. I already did this. Ah, yeah, so I did. Okay, we'll do a git pull on the Clojure test runner repo. Let's see, I will just wipe it out again. All right, so we will clone my fork. And we will clone the standard test runner. And so now we have, this simulates what will be done in CI. So we'll go into the one that we're using now and open up a code session. And now we can go into here and connect to a REPL and play around with it. Okay. All right, now the run script to find that let's see what the relative path is. Oh, just bin. Maybe just that. There is a Clojure repo path. But that's the So let's see how that... oh, it's right over here. We can see that's where it's using the Clojure repo path. Okay, but that would have been changed. Yeah, we can get the current working directory just with fscwd. That's useful. So like, why don't we just use that? If we go fscwd, huh? Oh, this probably needs to be called as a function. Yeah, cool. Let's just change it to that. I don't know. So then the run script will be relative to the current rate. I don't know. I'm just shooting darts here, actually, because oh, okay. Are we not using FS there? Let's see. This is in... Huh. Well, there it is right there. That's odd. Can't resolve symbol FS. Huh, so that's odd. Why wouldn't it be able to resolve that? Let's see. VB Clojure test CLJ. I evaluate that. It returns a path object. And that is the full path, which seems to be correct. But why wouldn't it be able to find FS? It's using FS everywhere. Now back to this one. Okay, let's see. -R. That is just perplexing. Okay, so let's step through what's happening with run all tests. And for the path here, you know, let's actually get rid of this for now. I'm going to take the code here, but then we're just going to do it for one exercise. So we evaluate get exercises, and this is what comes back. And then, well, we're just interested in the slug key is all. And it defines that as X for the exercise. So I'm going to isolate this part. And then wherever it says X, oops, we're just going to say the name of an exercise slug. Okay, so let's see what's going on here. We need to okay, so oh yeah, and slug needs to also be leap. Alright, let's see if this does something. Okay, no. I'll comment out these lines. Okay, then let's see. We'll test the see what the test directory is. So it's a temporary directory with this this crazy random number. So yeah, all of this looks fine, actually. So let's see what happens if we run all tests. Yeah, okay, so that's where it got to here. So it copied the exercise, and now it's the check test where it seems to fail. So if it copied twofer to the temporary directory, let's see if it's indeed there. So is that actually in the root directory where we see does it put it here? Oh, interesting. Let's evaluate this and all right, yeah, there they are. So it does copy it. Is there the one called leap? Let's see. Exercism, Clojure. So that's interesting. That it doesn't seem to it's defining temp dir, but then that's interesting. Let's see. Huh. Oh, that's interesting. Okay, so there's the test directory. Ah, okay. It's because it's because each time it is creating a new one. Alright, so now we have one canonical variable called temp dir. Okay, and there it is. So okay, here's our current temporary directory. We'll just go there. No, I meant to, oh yeah, I need to copy that over here. That's how it works. Huh, so yeah, it never actually copied leap. How about that? Let's find out why. Yeah, what I'll do is I'll just define this as well. right, now let's see what happens if we just run this. We get an error. Why would that be? Testdir itself is fine. Now it could be exercise path. And yeah, that could be the problem, is that we haven't set the Clojure repo path properly. Let's see. Yeah, it's .Clojure, where yeah, that could actually be the problem. Because we're actually trying to I've tried so many things now, I'm lost. That's what happens here. So I actually forgot what we were even trying. Now this the run script is supposed to be in the test runner but for now we'll do it this way, actually, and I will actually change this back to the Clojure repo path. And what we're going to do is change the Clojure repo path to what it should be. So by just, here's the options, and wait, that's it? That's just, and we will set it to, well, let's see, what? I will just take this directory here and like if I called fscwd, all right, now we just changed the Clojure repo path. So let's say we want to get the exercises. All right, so that still works. And now let's try yeah, let's just try this. Same thing. Exercise path leap. Let's see what that returns. If we just evaluate this sub expression. Oh, interesting. The exercise path function is not exercise path is supposed to take a map. That's why. Interesting. But here we're just passing it a string, a slug. Okay. The exercise is not supposed to be just the slug. Okay, let's see. So, yeah, where that says leap here, that's not how exercise path works. Instead, we're going to go get exercises and it'll be something like this. So for all the slugs of the exercises. So let's just grab the one out of here. So first we have to say exercises. No. Okay, yeah, so that already grabs all the exercises. Let's just get the one where the slug is I think sum is the best way to do that. I can't remember, but anyway, if we pass filter, a filtering function, so we'll get the one where the slug of the exercise equals, which one are we doing? Leap? Alright, now that's the exercise leap that should be passed in here to exercise path. Now let's just see if that works. cool. So, except no. It never changed. Oh, that's right. Okay. Yeah, I just did a. I returned a new options map here without actually redefining it. All right, so that's our exercise path, and now let's try doing the operation. So now, there is leap. Okay, that took a while just to get this far. All right, so now we want to check the test. And let's see, that didn't work. Oh, that's our error message that we were getting. Is that bash/r? Okay, interesting. So it looks like we might be getting somewhere now. Did I just crash the whole runtime, or no, I guess not. All right, let's see what this check test function is doing. Oh, it's run test. Okay, so that it runs the test. With exercise path solved. So let's try running this. Let's check just the check test part and see. Well, so the exercise is not the slug; it's the entire exercise, right? It's, yes. All right, so that's the leap exercise. The path to the exercise is, well, that's the test directory. Yeah, so that's actually fine. And Interesting. So it's this bash/r. Like, what is that? So yeah, it's something in this run test. Let's get this exercise here. This the leap exercise. And I'm going to first define that as just exercise. All right, now the slug is leap, and the path what is the path that is passed to check procedure or check process inherit? Let's see. It's the path that calls run test. Test directory, okay. That's the location of the run script. And let's see, the directory of the test. Let's see what that is again. Huh, interesting. Wrong number of args passed the process. So let's see how it's supposed to work. A vector of strings. Okay, run script is a string. Okay, maybe looks like here args are collected into a vector, so that should work fine actually. Check procedure inherit. let's look at some examples of process builder. Maybe that's the problem. That the test directory is not a string. Let's see, but we would have to say fs path. No. Yeah, because it's already being passed to fs path. How do you get it from a file system path back to a string? Is it str? Yeah. So it's still not finding the file, so that's interesting. What if this is not quoted? Does that matter? It's if we just ran this command. So let's try it. Let's see. What we needed was okay, so that's where we're getting our error. So let's see. Let's see, we want that there, or I think we actually want the Clojure test runner, and let's try yeah, let's try these args from here. Oh, interesting. Okay, so it looks like the whole problem is the run script. So when this is this, and then that gets defined as run script. Okay, so this is not good. What if we prefixed it with bash? Huh, interesting. So that's interesting. It's telling us where this R thing, where those are actually coming from. Apparently is the run script. Line 5. These are the blank lines. Okay, what is going on here? It's trying to run each line. Huh, so this is interesting. Let's try just redefining run script as this. Huh, interesting. It, no. Let's use that path string function instead of this. So this one worked, right? Yeah. I'm going to undo everything that I've done here so far. So I want to see how the run script normally runs. And actually, to do that, I will we'll make another test directory, and I'm going to clone a fresh copy of the test runner. And sure, we'll open this up. And yeah, so the run script is relative to this file. So let's see, we need path string. Actually, we need to connect to the REPL first. And we'll define path string and define run script. So that does what I thought we were doing. Let's try check, let's see. Alright, and we'll just try to run the test runner on an exercise. And we'll just use one of these. How about example success? Which will be the leap exercise. And we'll grab the path here. And, so that worked. So that's interesting. Let me search for this term and see if I get anything interesting. From Windows style line endings. Oh, that actually makes sense. Oh, wow. Okay, so that would be weird if this was all because of that. All right, let's run this sed script to get those out of there. We might actually have figured something out. Imagine that. Okay, here's the test runner. Test Clojure test runner. Okay, so all right, now the one, let's see, which one's the one in here? I'm just gonna I'm going to close all of the VS codes. And then open another one. That's weird. Where is the it actually just wiped out my file. Well, that's oh, yeah. Yeah, I wasn't supposed to do that. Okay, so I copied that. And, okay, let's see what happens. You know, it's showing no changes. Well, that's interesting. It could be because VS Code is actually switching it to Windows. Could be that is the problem. Oh. That's the one it was supposed to be. No? Still won't let me? It's no wrap, line wrap. No, that's not right. How about if I just cat the file in the terminal here? Oh. Now it's letting me change it. Let's see. Oh, it's doing the same thing. Wow, wow. Let's see. Actually, you know why? It's because it's this run script that it is running. Oh, no, it's running it from the Clojure repo path. So let's see. Which is being provided over here. Let's see. So anyway, I'm starting to run out of gas, I think. So I've done everything that, well, I've tried at least everything that I wanted to, and I have I've made it clear what I am trying to do. It's just too many things for me to figure out. But if I had someone help me that knew how to do this stuff, I bet we could get pretty far. So we'll see if anybody watches this video and it would be nice to put together some kind of issue or something. So yeah, that's the same run script that's being called, which, oh, you know, it would make sense if, did I actually modify the right one? Yeah, I sure did. And yep, same thing. Let's try this DOS to Unix thing. Let's see, we need oh, look at this. This is doing something different now. I might have actually gotten somewhere. So when run.sh is run, okay. It's looking for the test runner script in the wrong place, but that's because it makes sense because we shouldn't be looking for it there. we're supposed to look for it. Not here, but in the Clojure script version of it at that point. Look at that, it's actually running the tests. Okay, so now, wow. All right, so we got farther. Now it's this libs.jar that, which makes sense because it's in a different place at that point. Now, yeah, I remember getting to this point before when I was trying to fix the CI, and it was the problem was being caused by this libs.jar thing, and it might actually be the way that we're calling it from here, because now we're running this test runner, the actual test runner, and yeah, it probably just can't find libs.jar at that point. So what we're going to need to do is fix this, I guess, so that this contains more than just this path here. Even if it just had a dot, maybe. Let's see, how can we verify this? Let's see. Let's say we go to CI test, which has both of the repos as they are in parallel in CI. So now we're gonna go here. And then say we want to, well, first of all, let's show how it's supposed to work, I guess. So we'll open VS Code in the test runner repo. And we would connect to the REPL. Something just didn't work. Weird. It worked that time. All right. So we evaluate that, and then we add libs.jar to the class path. Okay. And the reason that works is because of the way that the class path lookup strategy works. And it finds it in the project root. But it seems that that doesn't work if it's being called from somewhere else. All right. So let's say we had the absolute path. And it's going to be the absolute path of you know, another way we could do it would be to copy the jar from where it is. Yeah, okay. That might actually work. Okay, there's the path. And let's see, this, where should this happen? This should happen actually just once in here. So when the when CI is run, we'll just run cp libs.jar and just copy it to like that. I don't know. Best thing I can do is try it. Oh wow, this might have actually worked. So that successfully copied the jar, and now we're just getting the missing snapshot files, which makes sense because, does it? Let's see. Let's see, maybe we just need to create them. We could run it with the update flag. And it's run from where? I can't think anymore. It's from the workflow. Okay, so if we run I think that's what we wanted. So, yeah, I'm not sure if we, actually, that might have been what we wanted anyway. So that, let's say there's a pull request that modifies the exercises. We're going to have to generate the snapshots for the right? Am I thinking this right? Now, let's see, this is taking a while because oh my god. I think that actually did it. It's done testing all of these. Because that's when it made the snapshots. Okay, that I think that makes sense. And then okay, so there's our error. Which, wow, this is amazing. Only one failed, and it's that robot simulator one, which we can fix by just we would go into the example solution, and it's going to be actually let's see what the what was the error message again? I can't believe I actually got this far. The function is arity 0, but it actually should be arity 2. What is robot supposed to take? So it takes a map and a keyword. So if we just said, but it's, what are they supposed to be? Coordinates? Coordinates and a direction. It's still going. Look at that, it's green. Okay. Wow, so amazing. I can't believe I actually did it. And at that point, it is back to a real integration test. I could prove it by deleting this patch script from here. So we just get rid of it. Oh, I didn't like that, I guess. No, that's not what I want to do. I just want to... oh, okay. We want to delete it from the fork. Oh, wait a minute. So what happened to the green? That wasn't the one that was green, was it? while that's waiting, let's figure out how to apply this to the actual Clojure repo. It might be, well, I guess we could just do this. Let's make sure that this is successful. This could actually be accomplished with as little as a pull request, I suppose. And it's green. Wow. All right, so let's see here. Okay. So to explain what the improvement is here is okay. Improves verification of exercises by also testing the unsolved source files. Okay, what else is better about this? All right, let's see what this looks like. And yeah, let's see the changes. Yeah, we changed the Clojure path from main to Clojure, and that's important. Then same thing there. Okay, the run script. The run script is just added because we need the one that runs from there. But then it knows where to find the test runner script in the other repo. Okay. Then wait, now this shouldn't be in here. These date parser ones should not be part of this PR, I think. Then that's where we changed Robot Simulator. And, okay, the libs.jar gets copied during CI. So that really should be there anyway, but that was kind of a hack to avoid having to change the place where libs.jar is being pointed to. All right, so this, okay, we'll get rid of all my old stuff and put in David's new stuff, which apparently works great. I'm just going to have to clean this up a little bit. So let's make it a draft. And yeah, I need to give credit to David for writing that. And it was written as, well, part of this one. Right? Here's where he decided to, I wrote another testing script which runs the current test runner against all the exercises in the Clojure track in both their unsolved and solved versions. Okay, so can I just link this, yeah. Copy link. I guess I can't tag him. All right, so kind of like a natural extension after finishing all the Clojure exercises, putting those skills into practice. If only everyone would, after they finished something that was made for the benefit of others, that they went ahead and tried to improve this, whatever the thing is. And here we talked a lot about, yeah, this is incredibly valuable because it could replace the test script we're using in CI, which is terribly crude in comparison. And I hadn't even gotten it to a stage where it's a true integration test. I got a bit stuck and had it on my to-do list, but this is actually much closer to what I had in mind for how a test runner should be. Cool. So I guess we're done. We have the PR here. Upgrade CI to new script. And let's see, so what actually needs to be I need to take stuff out of this PR that shouldn't be there, like this date parser stuff. I'm not sure why that ended up there. Didn't I just clone it? Or fork it, rather? I remember, interesting. And yeah, we probably want to get rid of libs.jar. Unless not. It's kind of a lot of stuff to be copying around for no reason other than that to avoid having to edit the Clojure test runner repo at all, but I don't know. How do I just get these out of here? Let's see. If I check out this PR, and yeah, actually it says how to do that right here. That's the conflicting file too. Okay. All right, so here, let's see. Is that? No, that's not right. Okay, yeah, that's what. Yeah, it is supposed to be like that. All right. Is this what I want? Commit updates to the main branch. Is that really what I want? It says there's still 9 files changed, which that should have gotten rid of these. I guess for some reason these changes were not made yet, so that should be taken out of this PR. I need to open this up in like VS Code or something, and just this is from here, okay. All right, I'll try. All right, so those are the changes. What is this? All right, now that should be all right, so I synchronized the changes there. Now cool, now we have files changed at just 6. All right. Libs.jar. Let's see, I should, yeah, actually get rid of that. All right, we removed the libs.jar, and wow. Okay, so I've been streaming for almost 7 hours, and I actually did well more than I thought. I remember at the beginning I said if we're lucky, we might make an issue at the end, but we actually got a PR. And wow, yeah, we learned a lot of stuff. We learned what happens if you have a bash script that has Windows line endings. And what else did we learn? We learned what was causing the problem that I couldn't figure out before, where, yeah, you know, actually there was a PR that I made. This was back in like April or May or something. When I couldn't figure out what was causing that libs.jar problem during CI. And that was when I said, okay, I guess it has something to do with that, but I can't figure it out. And so I did this, a temporary patch to get CI working again. And yeah, I was having the libs.jar file was not being added to the class path in CI because it's in a different location at that point. So I worked around the issue by using a local copy of the test runner script. But that's annoying because then it needs to be kept in sync. You're maintaining two copies of something, and it defeats the purpose of testing the test runner if you have your own version of the test runner that you're testing. And but that's great. So this will fix that. And, you know, I can probably change this to not a draft because this should be good to go. Now, since, hey, how's it going, John? I'm doing good for streaming for almost 7 hours. And this was, wow. So we upgraded the CI, and the only way I knew how to do that was to fork the repo and then keep trying it over in my user space. And we probably made like 20 changes or something to see if it would pass. And about an hour ago, I almost gave up because it was just... it got to the point where I was just going around in circles and I couldn't even remember what I was trying to do in the first place. And then it worked. All because this was what was messing me up for probably 3 hours or something. Is that there was a Windows line, there were Windows line endings in the bash script. And so I just used this program, DOS to Unix. And I was going to say then it worked, but no, then we just got to the next error. But I figured everything out, and now I'm actually out of stuff to do. So we have a PR, and this brings the Clojure track to a much better place, actually. Now that we are doing more in CI than just testing the exercises with their solved solutions, we're also testing the unsolved solutions, and this actually would open up the door for it to be more extensible to test other things, like the things that are tested over here, where we have all different kinds of failures and different kinds of solutions. Here's one that uses spec to make sure that that works, and with different kinds of, well, that's for, yeah. But yeah, mostly, wow, that was quite the marathon. So I think I better wind this night down before I get in trouble or something. So we'll go over here. And cool. So that should take care of the Exercism dev stream for a little while. And so maybe next time we will do some JavaScript, or who knows what else. So you can, if you'd like to support these streams, help me pay for this office studio space, then you can become a patron. Patreon.com/BobbyCodes. That's BOBBI codes.